Welcome back to the lecture series. In this lecture, we'll discuss about the block diagram of microcontroller PIC16F877A. So, my name is Dr. Husna. So, I'll walk in through the architecture and the core features of the microcontroller. Let's get started in. So let's begin with the introduction to the microcontroller. PIC microcontroller. The PIC stands for the Programmable Intelligent Computer, and it's a family of microcontroller based on the hardware architecture. Originally, it is developed by the General Instrument Microelectronics Devices, and these microcontrollers are known for the efficiency and ease for the implementations. Today, we are focusing on one of the popular models, the PIC16F877A. Why PIC is popular, so widely used? It because of its low cost, high availability and simplicity. It only has this 37 instructions to remember that make it easier to the programmer. Moreover, it is a programmable flash memory and efficient code of executions, and it make it preferred choice for non-complex applications. And it simply put, like, it is small, but can use small devices, but it will give the more performance, and it is an ease for the interfacing devices. Now let's compare the two different architectures. There is a two different architectures. One is a hardware architecture and von Neumann architecture. Controller uses the hardware architecture, which separates the program memory and the data memory buses. This allows faster access, and it supports the RISC or the reduced instruction sets computing for higher performance. On the other hand, the von Neumann architecture uses a single bus for both, like creating the like bottleneck. It is used. We have to use the single memory sharing devices for transferring and receiving the for program memory and the data memory. So now moving on to the architecture of PIC controller. It includes like memory, central CPU unit, a timer timers, counters, DAC, ADC, and it also supports the communications protocols like SPICL, parallel interfacing, USAT, universal asynchronous synchronous transmitter receiver, and it is making it more versatile, used in the various applications. Now we'll see the deep architecture, or deep into the architecture diagram. So here I have shown you the architecture diagram, where you can see the CPU block. Here it is, CPU block. The CPU is a central processing unit, and this central processing unit is a CPU, we can say, as a brain of a microcontroller. It consists of several components working together, like arithmetic logic unit, and this performs the arithmetic operations like addition, subtraction, and logical operations such as AND, OR, and NOT. And it is a decision maker for data manipulations. And accumulator, in CPU unit, we have the accumulators. That is the temporary storage space, which it results of operations performed by the ALU and are stored before being passed to the memory or the other unit. For example, let's say addition program, where we do the addition, but we get the carry. That carry will be stored here. That intermediate program passing value has been stored into the memory or the other unit. So the memory unit is this memory unit ensures the instructions and the data seamless between the CPU and the memory storages. Control unit, this coordinates the flow of data within the CPU, and it controls interactions between the peripherals and internal units, and it's like a traffic controller of the systems. Memory organization, uh, memory organization and PIC is like well structured to handle the diverse task. It consists of a program memory, and this is the non-volatile memory, which it stores the instructions that make the microcontroller perform its task. So it supports the 8K words of flash memory, so that can be erased and reprogrammed, make it reusable for iterative developments. Data memory, this is the volatile RAM, used for the temporary storages. Data memory is divided into banks such as containing special function register and general purpose register. Special function register is a predefined register which is dedicated to controlling microcontroller functions such as status, port, and tris. Tris is a tri-state on and off register. Next is a GPR, general purpose register. This register is used to perform the arithmetic operations, data manipulation, and storing the immediate results. And next is the data EEPROM. Unlike this data EEPROM, it is a non-volatile memory and it stores the data even after the power is turned off. It is ideal for saving the critical variable during the runtime and it can be accessed to the six specific SFRs such as econ and EADR, that is erasable advanced data reader, and timer and interrupt. So in timer and counters, a timer and counter is essential for time sensitivity operations. The timer is used for the delay or the measure the time intervals for the if because we use we have the multiple, it has multiple timers from timers time 0 to timer 2, which it operates, all can operate independently and in coordinations. Counters is like increment or the decrement based on the external clock signal and it is useful in counting pulses or the external events. ADC, analog to digital converter. This ADC converter converts the analog signal into the digital data for the microcontroller to process. This is particular useful in interfacing the sensors that provides analog output such as the temperature or light sensor. So it PIC supports up to the 10-bit of resolution for precision's analog to digital conversion. Next is the CCP module. CCP module is like capture, compare, and PWM thing. So CCP, it has three main functionalities like capture. Capture means it measures the time at which the event occurs by capturing the value of the timer. Compare is it compares the value of the timer register with the preloaded value and trigger the output when they have to match. And next the pulse width modulation, and it is used for generating the variables with pulse, and which is the vital applications like motor control and LED brightness. Serial communication module, which it supports the multiple communication protocols, and it is a versatile in connecting with other devices. Uh, so we have the two communication protocol. One is the USAT and another is an SPI. USAT is an asynchronous universal synchronized receiver transmitter. This serial communication is used for connecting microcontroller and to the computer, and SPI is a high speed communication protocol, that is peripheral interface, and this protocol is an ideal for the short distance devices connections. CAN is a controlled area network and it is commonly used in the automotive systems for the robust connection between the microcontroller. IO ports is used for the interfacing with the external devices like port A to port E, and it is for example we have the five different ports in memory, but port A to port C are the bidirectional, which it can be configured for both input and output for using the tris register. These ports make it possible to connect the LEDs with sensors and more to the controller. Oscillator, it provides the clock signal to synchronize the microcontroller operations. So PIC supports the internal and external oscillator and it allows the flexibility for timing and control speed customization. Next is an interrupt. Interrupt system allows for the microcontroller to respond the high priority task without delaying the ongoing processes. It supports both the hardware and software systems, enabling the real-time application efficiency. In next lecture, we'll see about how that we use this microcontroller, right? So what I do is in next lecture we'll see about how this we with this microcontroller we can able to design a program and run the program in the system. That we can see with the instruction. I'll show in the case study with the program next upcoming videos. Thanks for watching.